Hey everybody. I decided we were going to skip ahead and leave the animal world behind and start dealing with our human impact on the environment, starting with non-renewable resources. Non-renewable, this is where the fossil fuels and stuff will come in. So we've decided to move ahead a little bit. Uh, Time's running out. Okay, and we want to make sure that we can deal with the whole reason we're learning environmental science is that you guys are about to be grown-ups. You guys are about to be in the world, and these are the kind of situations you guys are going to have to deal with in fixing the world, fixing the universe, dealing with voting situations, and some of the best ways to deal with that stuff. So here we go. All right, so oil and natural gas. The case study is fracking, which is a fun word to say. Be sure you get an A and an R in there instead of a U. Just be careful you say it the right way. But fracking is a new thing that they're doing to stretch out our oil reserves and our natural gas reserves. It's a way to get more out of the land than what we were able to get before. And so if you're talking in terms of, yes, we need the fossil fuels so that we can have the energy to run the power plants, it's a good thing. But if you're talking about what does this stuff actually do to the world, do to the environment you're pulling it out of, it's horrendous. All right, so there's always going to be two sides of every coin, and that's one of the things I'll try to present it without bias, but this stuff just sucks. Okay, this is just wrong. So what this fracking does, and there'll be a picture for us in just a second, but oil and natural gas are our two most widely used resources in the U.S. All right, so if we want to run our power plants, we want to keep our lights on, we want to keep charging our devices, we're going to need some of this because this is what we use primarily in the U.S. And oil consumption is increasing. Okay, so we're going to have to get new extractions out of oil shale because so oil shale is like a rock that, think about when you trying to do oil, you think of like the liquidy oil pumping up out of those big machines in Texas, right? Well, this is oil that's trapped between the rocks. And so it allows us to get a little bit more out. All right, but it is very, very environmentally dangerous. Okay, and then burning the oil and natural gas is going to continue adding to the greenhouse effects, the carbon dioxide in the atmosphere and whatever. So what we're trying to get the idea is don't keep trying to find new ways to get oil. Try to find ways to replace the oil. All right, so this is what we're getting to. So the question there is, how is the energy produced that you use? And I keep looking this way because it's on the stuff behind my head is on the projector up top so I can see what it says. All right, but the oil that we use is mostly from coal. The oil in this area is mostly from coal power plants. It'd be nice if we could do that. There is some solar, especially out by Shelby Farms, but I don't know if that's enough. Shelby Farms, and then a little further out, I don't know how much of the city that actually does produce, but this is what fracking looks like. All right, you take these wells down and you shoot super heated gas, water, super heated water in there from one. Okay, the lower one it looks like, and then it brings up the oil from the other one, but it actually creates tiny earthquakes. To answer these questions in your book, the case study right at the beginning of the chapter. Okay, the case study is right at the beginning of the chapter, so you can use that to answer these questions for you. All right, so the it's technically hydraulic fracturing is the whole word, but fracturing or fracking is the short-term word for it. So it allows us to access hard-to-reach oil and natural gas, and it's a tertiary extraction method. That means that we got the big oil, all right, and then we got the gases that we could get, and this is a way to get a little bit more out of it, just squeeze a little bit more out. So it's a tertiary extraction method. It allows the oil companies to access oil and natural gas that's trapped between rock layers. All right, so it gets a little bit to reach, a little bit harder to get to oil, and mostly it's for natural gas. So the fracking involves using high pressure pumps to inject huge volumes of mixed water, sand, and chemicals into the horizontal wells. So these wells go straight down. You send this water. Now this water is not clean. It's full of water, sand, and chemicals. Okay, so when that stuff gets into the water table, okay, that water is going to mix with the water table and start to pollute the groundwater. All right, this mixture then blasts through holes drilled in the underground to send it back up. So you send this high pressure water down, and it sends the gas up, all right, to be collected. And then it's the mixture that's injected into the wells has naturally occurring salts, toxic heavy metals, and radioactive materials that are leached from the rock. So when this stuff again mixes, is potentially harmful drilling chemicals, and after the fracking is complete, about half of that mixture remains below ground. Okay, and it's becoming wastewater, and it's mixing with the regular water that the deer and the antelope are trying to drink. All right, so it's damaging the water. So processing this hazardous waste water is a challenge. So the environmental companies who are the oil companies who are trying to do this correctly, they will collect this wastewater and then clean it. Okay, it can be done, but it's very, very difficult, and most of them don't even bother. Okay, so the ones who are trying to do what's right will try to clean this water up, but it's very near impossible. Most of them don't even bother. Okay, it's going to get into the holding ponds. It's going to leak out of there. It's going to get into the sewage treatment plants that are, not equipped to handle this really well. And sometimes you can kind of try to clean it up and then reuse it for fracking again. Okay, but it's not, like I said, only the ones who are trying to do it right take this extra step. They'll clean it up and try to reuse this same water, but it's really, really expensive to do, and therefore, like I said, they don't bother. And so some say fracking marks a new era in oil and gas production, because we are able to get a lot of natural gas out of it, and most of our current electric companies can switch to using natural gas, and so we can run our electric companies, and it's a very good thing. So the oil people are very pleased with it, but the process is going to get less net energy compared to the traditional production. Net energy we're going to talk about in just a second. Okay, but think about what it might mean. So net energy would be however much energy it costs to make and to do. How much energy do you actually get to run your light bulbs compared to how much energy it cost you to get this happened? Okay, so that's your net energy. We'll talk about that again some more in just a second. Okay, so the oil and natural gas prices have to be high in order to make this profitable. This is really, really, really expensive to do. This is crazy expensive to do in general. So the only way it makes any kind of sense is if oil is really expensive to begin with. So it's real expensive to do, but if they're going to pay you a lot for your oil, okay, then it's worth it. But if the oil prices come down, or if we finally come to our senses and stop using oil, okay, then there'll be no reason to do this because it costs so much to get it done. Okay, this is our real fuzzy gray box. I'm sure you can see yours. We did our gray box. It's already been assigned, so you should have it done, and there are 3 checkpoints in this gray box. One thing about this chapter is we are combining 1 and 2, because 1 and 2 is basically about this net energy. And once you get this idea, how much energy does it cost to make? How much energy do you get at the end? Subtract those 2, that's your net energy. So we're okay. All right, so this section 1 we're just going to kind of flip through, and most likely I may stop the video at section 1 and then make a second video for section 2 just for time's sake, because you guys need this now. Okay, yeah, I've already assigned the notes, and so you really need this video. All right, so what is net energy and why is it important? So to supplement the sun's life-saving energy, the society produces commercial energy, right? Because the sun is steady shining, and all energy basically starts with solar to begin with. Even oil started from plants. Okay, so yeah, everything. So the sun's life-sustaining energy, we make commercial energy, energy that's sold in the marketplace, and it's produced from either renewable or non-renewable. Okay, so commercial isn't necessarily bad. Okay, commercial energy is not bad. It's just what we sell. Okay, and again, you guys, this is where it gets important to you and your life. All right, you are fixing to be old enough. Some of you guys may already be doing it to pay an electric bill. Okay, so this is real important. MLGW, how do they run? What are they going to charge you? What's coming out of my paycheck? This is what we're talking about. Okay, so the non-renewable resources exist in fixed amounts. So there's only a certain amount of the non-renewables. These took millions and billions of years to form. They're going to be used up way more quickly than they can be replaced, if they can be replaced at all, and a lot of them can't. Okay, these are our fossil fuels like the oil, coal, natural gas, mineral deposits, nuclear energy. Okay. Oh, I'm going to pause this. Hold on. Okay, I just recently found that pause thing. Before I would have to actually start the whole slide over, and it's like, nah. Okay, all right. So what we were talking about the types of fossil fuels. Okay, coal, oil, natural gas. We got those. But also within the non-renewables, we also include minerals and nuclear energy. Okay. Now, all of these are, they took millions and billions of years to form. We're going to use them up way faster than we can get them replaced. And the thing about especially oil um, comes from and way back evolutionarily, we had trees. Well, they weren't trees. They were like giant house plants. I mean, house plants the size of a tree. Okay, so they had the soft stem like a house plant would, and whatever. It's like a house plant the size of a tree. And at beginning evolutionarily, there was nothing to break down or digest the stuff is called lignin that was in the cell walls. Nothing in the world had evolved yet to digest it. So those trees, when they would die, would just stack up and stack up and stack up. Nothing had evolved yet to digest that lignin. Okay, so when this, I want to say it's a fungus, finally evolved to digest the lignin, well, then they could break it down. But until then, they had been stacked up and then one on top of the other. You remember how sedimentary works, right? They stack up and the bottom levels get squished and squished and squished. Have you ever kept a like a bouquet a little bit longer than you should have? Like, I don't know, gentlemen, I don't want to speak to anybody, but when I get like flowers for my birthday or something, I'm so pleased to have them. I keep them on the table probably a little longer than I should. All right, when I go to throw those away, I lift them up out of the water and this, yeah, I'm sorry. Okay, there's this brown gooey stuff on the roots, on the stems, okay, where they have started to rot, this brown gooey stuff. Okay, so yes, apart from my housekeeping, you bring this to the whole idea of these trees that are not being decomposed. They just stack up and stack up and stack up. Can you imagine how much brown goo would be around these roots? This is how we started oil. But the thing about it is now we have stuff to digest the lignin. So it's not going to sit in the ground long enough for this stuff even to happen. So there is no way to get more. No way to get more. That's why we don't want to use up all that we have. Okay. All right. So then the renewable resources, these are the good ones on that third bullet down at the bottom. Okay, and I'm reading behind here because my face is in the way. All right, so the renewable resources, they're replenished by natural processes. This is the wind, the flowing water, which is hydropower, the sun's heat, which is solar energy, biomass, which is good, the energy in plants. That means we can use like vegetable scraps for oil. This is really, really good, the stuff we are done with. Think about when you are, what's one of them? Like a vegetable where, like for our house, broccoli. Okay, we eat the tops off of broccoli. We will not eat the stems. Okay, those are just hard and chewy and just, they taste bad. Okay, we'll eat the tops of broccoli, but we don't eat the bottom. Biomass is a way to take that stuff that we're not going to eat and get energy out of it. So that's chapter 13. So when we get into the next chapter, it gets really exciting about the stuff we could possibly do. Okay, and then of course geothermal, which depends on where you live. If you live near a volcano, you got this, but we don't live near volcanoes. Okay, so the part of section 1 is what is net energy and how it's important. So most of the world's commercial energy is produced using non-renewables. These are the bad ones. In 2014, this book was made in 15. Okay, so 2014, 90% of the commercial energy used worldwide in the U.S. came from non-renewable, mostly fossil fuels, coal primarily here in the U.S. About 10% came from the good stuff, the renewables. So the questions here are the energy resources used at our school renewable or non-renewable? And that will determine what is MLGW, and it wouldn't hurt you to look at it to see, because like I said, you'll be paying bills real soon if you're not already. Should our school consider using different energy sources? Explain. Now this is an obvious question. We should. The trouble is, how will we get to them? Okay, I know that Shelby Farms has a, like I said, and you need to answer these questions in your notes. Shelby Farms has a solar farm, and there's one a little further out, next county over. I don't know if Mississippi is running anything that could bring it up here, but it wouldn't hurt to see who all is. But here's the thing, that's solar. Wind power we have in gajubels. Okay, all we need to do is set up the turbines. Okay, so we could do wind power easy. That's another thing that we're going to learn in next chapter. Wind power is the best bet for almost everywhere. All right, but we'll get there. I got to tell you the bad news before we can do the good news. All right, so it takes energy to make energy. Okay, this is where we get the whole net energy idea. So for example, before oil can be used, it has to be located, pumped up from the ocean floor or from underground, then transported to a refinery, then converted to gasoline or diesel or whatever it is going to do, and then delivered out to the customers. Okay, that's a lot of energy to make that happen. Okay, so each of these steps uses high quality energy that's obtained by burning fossil fuels, especially the gasoline and diesel fuel to drag it around everywhere. So because of the second law of thermodynamics, just to make that sound good, okay, some of the high quality energy is used in each step is degraded to lower quality energy. So when we think about when you pump gasoline in your truck, okay, that is good high quality energy that you're putting in your car. Then you drive your car. It's converted to heat and fumes. That's low quality energy. This is what we're talking about. So everything starts off with good high quality energy, but then in the using of it, it becomes low quality stuff. Okay, that's what the second law of thermodynamics is talking about. So most of this energy is wasted as heat or released out into the environment. So the question in the box, again, I'm reading from the projector, is how efficient is an energy source if it gets 20 units of energy, but it takes 15 units of energy to get that source? This is the kind of thing we're talking about. So let's say, again, it doesn't matter what the unit of energy. It took 15 units of energy to get it. And once you got it, you only get 20. So that means you only get a net balance of 5. That's not really great. Okay. So it took you 15 to get it, and you only get 20. That means you've got a balance of 5. That's all you really get to use. And so this is why this net energy thing is important, because when we go to decide, because the whole thing is we're always trying to decide what type of new energy resources can we have, because we know fossil fuels suck. So we're trying to decide which one to use in its place. This is where we get the idea of net energy. How much does it take to get it, and how much are we going to get in the end? So this is the whole idea, and so this is what we use to decide which path to follow. And again, you guys will be doing this. This is the whole reason. You guys will be deciding this sort of thing in as you're voting when you get older, making policies. Okay, so you will need to know, how do we choose which type of energy is best? Okay, and this is what this is for. So net energy is the total amount of useful energy available minus the energy needed to make it occur. Okay, so net energy is the energy output minus the energy input. Okay, and so the different energy resources vary greatly in their net energy, and that's what we're going to use to determine or kind of make assumptions as to which one is best. Okay, so what is their net energy? It took me this much to get it. How much am I getting it from it? So the scientists are going to look at the net energy as the best measure for determining long-term usefulness of an energy source. Like I said, we're trying to decide how to change policy or how to make things new. So if the net energy is 0 or negative, then it can't compete in the marketplace. Okay, if the net energy is 0 or negative, worse, then you can't take it to the marketplace. But if you're going to try to use it anyway, you're going to need subsidies from the taxpayers. You're a taxpayer, or you will be very soon. So if somebody in the government is trying to use one of these 0 net energies, they're going to get into your pocketbook to pay for it. They're going to have subsidies. Now, the nuclear example on 388 is one of the ones that shows you what's going on with this. And so the main purpose of energy subsidies, what is that? Okay, so energy subsidies, that means a subsidy in general is basically that the government is paying half your bills, or somebody is paying your bills, because you're trying to bring something to market, and it's costing you so much to make it or to get it or to do it that you can't pay your bills. And so if the government or whatever determines that they want your thing anyway, whatever it is you're trying to sell, then they will help you pay your bills so that they can keep getting this to the market. Now, what it is subsidies in general, subsidies by themselves are not bad. What if I was trying to bring something good to the marketplace? It just cost me so much to make, but I was trying to bring something good. Well, if somebody wanted to pay half my bills and I was able to bring this good thing, then subsidies are okay. But if I'm trying to, if there's a whole lot of ways that these subsidies can go bad, a whole lot of ways. All right, we'll talk about subsidies here in this chapter, but if we get to the food chapter, oh my God, what the government will pay for in order to bring food to the marketplace. Subsidies in themselves are not bad, but they can go bad very, very easily. And I know we'll be talking more about subsidies. All right, so, oh, good, we're done with section 1 already, so I might be able to go ahead to section 2 because I'd like to have them both. Let me see. Yeah, we might get through all the way through. Okay, good. Okay, so you got this. Based on what we've just said, you can fix this. Usually we do our core ideas in the on the study guide, but I've got them right here. I don't know if you'll see them a second time, but go ahead and answer these questions based on what we've just talked about. All right, moving on to section 2. I'm so glad we can do both. I told you section 1 was really short. Now this one is going to get a little longer because this is the fossil fuels. Okay, this is where I'm going to start, screaming about stuff. I won't start screaming, but I will be argumentative when we start talking about using these fossil fuels. All right, there are 6 checkpoints in this chapter, so when you get to the second gray box, just make sure you don't miss any. All right, so advantages and disadvantages of fossil fuels. Okay. I say there are some advantages. I'll try to be as honest as I can. Okay, so crude oil or petroleum is a mixture of hydrocarbons that formed over millions of years from decayed remains of ancient organisms. Do you remember what I just told you about the plants? That they were rotting, right? All right, because there was nothing to digest the lignin. Well, this is what we're talking about. Okay, so the petroleum is made over millions of years from decayed remains of ancient organisms, and it became crushed beneath rocks of layers and subjected to intense pressure and heat, and consequently, the oil is a type of fossil fuel. All right, because it comes from fossil plants, right? The oil deposits form when the extreme pressure caused from the overlying rocks, remember I said it was sedimentary rock pressure, forces, and again I'm reading from the PowerPoint, the projector, forces the rock up through the cracks and pores in the earth crust, and then it's trapped in a layer of impenetrable rocks, and it collects there, often with natural gas kind of floating on the top. And then it fills up the pores and the cracks like water soaking into a sponge. All right, so you have these layers of rock, and then the oil is trapped between the layers of rock, and the gas is usually floating right above it. All right, so the conventional crude oil is abundant and is therefore the most widely used energy source in the U.S. It has a medium net energy, okay, so based on how much it spends to get and how much you get in return. But using it causes air and water pollution, releases greenhouse gases to the atmosphere. We know how bad oil is to use. Now, this unconventional heavy oil is what we get from the fracking that I was telling you about at the beginning, okay? You take that oil shale rock, and what that is oil shale rock is, and then tar sands, what they are is instead of having a puddle of oil where you can just slurp it up with one of those oil rigs like a straw, okay? You don't have just a puddle of oil. Okay, what you have, it's like trapped between the rocks and in the rocks, and you actually have to destroy the rocks to get it. And think about tar stuck in sand. How difficult would that be to get the tar and separate the sand out? And that's what they do. Almost all of Canada has been ruined. All of the beautiful tundra, all that stuff, because Canada has a lot of tar sand, and they are ruining the entire ecosystem up there to get the tar out of the sand. It exists in potentially large supplies, but it has very, very low net energy, how much trouble it takes to get it out of the sand, and you get just a little bit of oil. So this is one of the ones that you're going to have a huge impact on the environment in order to get it out of the sands, and you get this little bit of oil. They're also going to need huge subsidies. So the people themselves are paying for this. It's destroying their environment. It's destroying their nature. It's destroying their woods, and they are still paying for it, and they don't want to. There's a lot of argument about subsidizing these tar sands because it's a mess. They don't want it, but they want to have their little share in the world oil market. So here, we got some oil to sell too. Give us your money. So they want to have their little share of oil. But it's such a huge environmental impact. It is ridiculous. And it takes all of that work and you get almost nothing from it. Crude oil has to be processed in a refinery before you can use it for fuel. And the stuff that comes out of the pump, you have to process it first. The oil gets transported to a refinery by pipeline or truck or rail or ship, and that means you're using gasoline and fuel to send fuel. That's the thing. You're using fuel to get fuel. So it cuts into the net energy. At the refinery, the crude oil is heated and separated into the various forms. I've got a picture on the next slide, I believe, that I'll show you. And like all the steps in oil production and use, refinery requires an enormous amount of energy to get it and to make it happen and to do it, and therefore its net energy is going to go down. Yes, here's my picture. All right, so down again, my face is in front of it, but you'll see it when you're looking at yours, okay? So on the bottom, okay, this is where, yeah, over here on this furnace, this is where they truck in the oil that they get out of the rigs, down here on this side where the furnace is, and they heat it up. And because of how it is, different temperatures of stuff will sort itself out. If these are one-way valves going up through here, then what you're going to have is you're going to have the very lightest stuff on top, right? Once you burn this, the very lightest stuff will go to the top. That's gases for natural gas, okay? The next lightest is going to be the gasoline for your cars. And then beyond that, again, these are one-way valves, so they go up here and the lightest things will go to the top. The next level here is for aviation fuel, and then heating oils like kerosene and butane and stuff. Then you get diesel truck oil, and then naphtha, which is turpentine, paint thinner, all right, and other stuff. Down here, you're going to have grease and wax, and then at the very bottom, you get asphalt. Okay, so you can actually picture these different things of the petroleum products. All it does is require heating. Okay, but this is a lot of heating. I mean, crazy hot temperatures. So you're using coal and oil and natural gas in order to run the furnace. All right, you've got to have coal, oil, natural gas to run the furnace. You had to have coal, oil, natural gas to bring it to the refinery. So all of that is going to eat into your profit levels. Okay, as you kind of think of net energy as profit levels. So society is currently depending on oil. So after about a decade of pumping, the pressure in a well is usually dropping. So those big pumps that they have in Texas, they only last about 10 years. Okay, and then the oil production starts to decline after 10 years, and you've got to have more. Okay, so you've got to shift those, or usually they have big oil fields, and that oil field will last about 10 years, and then they have to go find something else. At this point, at the point where it starts to decline, you say that you've already reached peak production. Okay, so you're done at peak and you're headed down. And the same decline production can take place over the whole field where many wells operate together. So the peak production officially is a time after which production of a well declines. Global peak production over the whole world. Okay, we've already reached global peak production. So there is not going to be another bounce of oil. We've hit our peak and it's already moving down. Okay, for the whole world, the whole earth, there's nothing else. Once we reuse up everything we've got in this earth, you've got nothing else. This is one of the oil fields that I'm talking about. And so there's some questions that I have on here. This it has some descriptions. This is a oil field in Southern California, and give you some basic information. I want you to answer in your notes, what do you think about this as you look at this picture? Okay, tell me what you feel about it and what you think. Just in with your notes there. All right, so now, are we running out of conventional crude oil? Our proven oil reserves, which those are the ones that are known, which oil can be extracted profitably at current prices with our current technology. So at the current prices, with the current technology, we can get oil profitably. That's what we call proven oil reserves. The number of them is not fixed. Okay, so it depends on how much we're trying to pull out. Okay, the demand. How much oil are we trying to get out? our technology. If our technology improves, then we might increase our proven oil reserves. How fast are we pulling it out? The rate, the cost of making it available. Remember, we said that our profit margin, and then the market price. How much are they paying us for it once we get it out? All of those things are going to factor into the amount of proven oil that any one country would have. So can we increase our oil supplies? Okay, higher prices and more efficient technology will turn previously unavailable oil profits into proven oil reserves. This is why we're doing fracking, right? It's a new technology. It allows us to get more oil. Okay, that's what we were learning in the case study, what we started off with. So higher prices or more efficient technology can give us more proven oil wealth, proven oil reserves. That's the word. Okay, so the horizontal drilling involves drilling the vertical hole. This is what we talked about at the beginning, 90 degrees down, blowing water, okay, and then bringing up the gases and any oil that can come to the top. All right, yeah, and that just describes, again, what we were just talking about. Are there other ways to get crude oil? Okay, well, we definitely have the offshore drilling in the deep seabeds, okay, but that requires drilling areas like the Arctic, which is very, very, very delicate. And half the time when we drill those places, those oil pipes leak. They get oil everywhere. They ruin the economy. Drilling itself is going to ruin the land. These are a lot more harder and a lot more expensive to extract, and you get, therefore, the net energy is going to be much, much lower. And again, remember, whenever the net energy gets too low, if the government wants it anyway, they're going to give that person a subsidy to keep it coming, which the subsidies come from our wallets. Okay, so remember that if somebody is choosing, if one of the governments is choosing this lower net energy on purpose, they're going to need to subsidize the maker, whoever's getting the oil company. They're going to have to subsidize the oil company, and subsidies come out of our pocket. So we have to decide if we're going to let them do this. All right, so they're harder and a lot more expensive to do. They're going to get lower net energy, greater environmental impacts, and higher oil prices. It hasn't started third period yet, has it? I'm sorry, I'm trying to do this on my off period. Not yet. Soon, though. Okay, we'll see how far we can get. So you're going to get worse environmental impacts, and the oil prices are going to be higher and higher to pay for this, or you have to pay subsidies. Once global peak is reached, the net energy is going to keep declining and prices are going to keep going up and up and up. We're looking at apocalypse type stuff where they're fighting over gasoline. Okay, that's the type of thing that's going to happen. Okay, so every one of our subjects, like we just now did oil, crude oil, okay, we'll have a slide like this that has advantages and disadvantages. Okay, when we're in a traditional classroom, I have everybody make a table of each of these blue things, and I might try that as one of our assignments, just copy and paste these blue tables for each one, but I'll have to see how it goes. Okay, but anyway, so the advantages basically of crude oil, we have plenty of it, enough at least for a couple of decades. It has a medium net energy and basically low land disruption. When you talk about the oil fields, fracking, it is not low. Okay, it's also kind of efficient because we've been working on it for a really long time. The disadvantages, water pollution from the oil spills, leaks, air pollutants when you burn it, vulnerable to international supply interruptions. International supply interruptions. That's when we go to war with other countries over oil. They may tell you we're going to war because they were bad to their people. We need to go get rid of them. They were ugly to their people. They're doing all sorts of civil rights injustices. We need to go to war over there. This place, they are so horrible to their women. They make them wear these masks and whatever, and that may be the case. But when we go to war with these people, it's not because we care how they treat their people. It's because we want their oil. Every single time that we've gone to war, it's not been about that the other people are bad. That's what they'll tell you in the news. It's because we want their stuff every time. Anytime anybody goes to war, it's because somebody wants somebody else's stuff. Okay, so that's what, so the oil is very, very vulnerable to international supply interruptions. Okay, war. All right. All right. And so within our uh, within our crude oil production, we have. I want you to look at this chart and answer these questions in here for me. This would have made a great worksheet. I might see if I can do that still. All right. So what country has the largest oil reserves? What's the percentage of the oil does it have? Yeah, I'm making you guys a worksheet for this. I'll have it up for next week. I'll try to have that up for next week. All right. And again, how can we increase the oil supplies? As the proven oil supplies decline, the world's going to have to turn to the unconventional heavy oil or tar sands. Okay, the proven reserves are declining, so we're going to have to look to this heavy oil or tar sands. The heavy oil is thicker, more sticky than the regular crude oil. The heavy crude comes from the depleted oil wells. So once the oil wells are out, we're kind of dredging the bottom to see what we can still get. That's where we get to the heavy oil. You can get it from the oil shale or the tar sands. Now the tar sands is like a mixture of clay, like I was telling you in Canada, clay and water and thick tar-like oil. It has a huge environmental cost to get either one of these out, and much, much higher production cost. So the net is going to be a lot less. We could increase it, but is it worth it? All right, so we are basically running out of oil. End of discussion. We're running out. So what are our options? We can live with the higher prices. We can expand the oil supplies, which again, expanding the oil supplies means trying to go to this heavy oil or the tar sands, and that's not a great option because of the damage that it does. So we can live with the high prices. We can try to expand our oil supplies, or bing, 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 we can try to use other energy resources. Try to use other energy resources, and that's what we're going to need to do. All right, I'm going to pause this here and come back. All right. So that I think it's time for third period to start. So I'm going to try to do this in bits and pieces today. We'll see how it goes. Well, that was very interesting. Whoop, hold on. I took a break to welcome in third period, and now there's somebody in third period needs back in teams. So hold on just a second. All right, so we'll just see how this goes. All right, so the question is, we talked about crude oil and how it's running out, and in order to get any more, we're going to have to um, turn our eyes towards this heavy oil and this tar sands that are so much more difficult to get to, and we're not going to get as much energy, and it's a heck of a lot of environmental damage. So the next question is natural gas a better alternative? Okay. Derek Roy to report to the attendance office in C building. The office in C building, Derek Roy. Please send him to the office in C building. Okay, this is going to be so much fun. Okay, so the next question is natural gas better? Okay, so natural gas is it's a mixture of gases. It's a lot more plentiful than oil. We have a lot of it. Okay, 50 to 90% of the natural gas is methane. Okay, but you also have kerosene and butane. Some of you guys have heard of those, but most of it's methane. It's a lot more of it available than oil. And natural gas is provided about 1/4 of the energy consumed in the U.S. and about 28%. 1/4 of the energy worldwide and 28% of energy in the U.S. since 2014. All right, so it's about between 1/4 and 1/3 of the market is natural gas. It's very versatile. Okay, you can use it for a lot of stuff: cooking, heating, industrial, motor vehicle fuel. Okay, we can run our cars on it. Power for the turbines, to spin at the electric company. It's a medium net energy and a pretty low production cost. Okay, because it just comes up with us with what we're already doing. The oil we're trying to get, the everything else that we're trying to do is already set up, and we get natural gas from doing it. Okay, so it doesn't have a lot of production cost. It's pretty low production. It's considered a clean burning fuel when it's burned efficiently. It's also cleaner than oil and much, much, much cleaner than coal. Okay, so it's definitely cleaner. By cleaner, we mean how many bad gases are put out or pollutants or toxins. If you're burning methane, you're definitely going to get carbon dioxide added to the atmosphere. But if that's the only thing, then you just have to worry about how much carbon dioxide. Okay, carbon dioxide itself is not bad until you get too much of it. Okay, so it's not a poison necessarily. All right, so the deposits of natural gas are often found above the deposits of crude oil and then tightly held between shale rock. Remember we talked about that fracking thing? Okay, where you throw the water in and it comes up. The natural gas is one of the first things that comes up, and so all we have to do is collect it. Propane and butane are the gases that come out first, LPG, liquefied petroleum gas. That's what comes up first. It can be used in rural areas. If you can't just get regular energy or pipelines from the city, if you live in the rural areas, what they have is big tanks. They look like a giant silver cylinder, like a giant pill capsule. All right, and a giant pill capsule in the back of a person's yard, and then the trucks will come in and bringing liquefied petroleum gas and fill up their tank, and then they can run their house on that. When I was young, we lived on a farm, and we had one of those propane tanks in our yard, and they would come and fill it periodically, and we would use that for our energy in the house. And so if you're too far away from, you can tell I'm a country girl now. If you're too far away from the city, that's what they do. They give you a tank of propane, and then they'll come deliver it to you periodically. The rest of the gas that comes out of there is mostly methane, which is CH4. You purify that and put it into the pipelines, and you can deliver it over land and also sea by liquefied natural gas. So what was the other? So this, oh man, I'm going to have to go backwards. If I go backwards, it messes up the video. The other one was there it is, liquefied petroleum gas, LPG. Okay, that's propane and butane. This is liquefied natural gas, which is methane. Okay, that's the difference. Why wouldn't they just say propane and methane? I don't know. You can't be that easy. Okay, LPG is the propane and the butane. LNG is methane. All right, so the methane is at high pressure and low temperature. Okay, really, really high pressure and low temperature. They just about as much as they can freeze it because it's a really, really flammable liquid. Okay, so they carry it in refrigerated tanks. And when they get to the destination port, it's heated back up and converted back into gas to go through the pipelines to wherever it is it needs to go. But this stuff is dangerous, very dangerous. So you have to keep it under really high pressure and really cold temperature. Otherwise, you're going to have an explosion. Can you imagine sending this out on tanker ships? All right, if one little thing goes wrong, your ship goes kablooey. All right, it's very, very dangerous. But that liquefying it in order to ship it out is crazy expensive too. All right, so if you're trying to if you leave it as methane gas, it's easy, it's available, it's everywhere. It's easy enough to send it down the pipelines. But if you are trying to ship it somewhere and you have to liquefy it, all right, that is incredibly expensive and is going to increase the cost of the thing, just skyrocket it. All right. And here's another set of questions. Like I said, I really think I'm going to put these onto a worksheet for you so that you can go through and you can see globally where everybody stands with these. Because again, every time we go to war, it's because somebody wants somebody else's stuff. And this lets you know who has what stuff. Okay, this thing. And so when you are looking globally at the temperature of, everybody's mood, this one wants to fight that one and that one wants to fight that one, and you have to decide for yourself right now, are you going into the service and are you going to be one of the ones fighting? And when you get older, you have to decide, are you letting your kids go? It's like nobody wants to let their kid go out into the fighting, but knowing who has what stuff gives you an idea of the global temperament to know where the next wars are coming up. Because again, every war is fought over somebody wants somebody else's stuff. Okay, so this kind of thing here lets you know who's got what. And so we want to know now, how does crude oil and natural gas compare as far as energy resources? So I put the crude oil back up over here and then on the blue tables to let us know, how does crude oil and natural gas compare? Which one's cleaner? Where do they collect within the ground? Can they also be collected through fracking? Does U.S. production and consumption, where do we import this stuff? How easy is it to transport it around? Remember I talked about that freezing thing that it may blow up? Okay, so this will help you answer these questions. And again, like I said, I'll put this together on a worksheet for you. Okay, natural production and fracking in the U.S. Okay, so fracking again is using those wells. Okay, it takes huge. It's not a well. It's like it shoots a pipe down of high pressure water, and then it comes back up with the gases. Lots and lots of water. And then sand and chemicals. The wastewater is toxic. You have to transport the natural gas, which adds a lot to the cost of it, which means your profit is going to be less. It has crazy bad environmental effects. It's horrendous on the world. Okay, the water issues, you're going to pollute that wastewater. You have gas contamination in the water. Oh, wait till you see on this next slide or the one after. Gas contamination in the water. Okay, just hold that in your head for a second. You have a lot of air pollution, methane emissions. Methane, okay, you know that carbon dioxide is heating up the world, right? You know carbon dioxide is the main problem when we talk about climate change and global warming. Okay, because there is so much carbon dioxide because of, everything that we burn puts off carbon dioxide. Now here's the thing. Methane, it's not the one we hear about most often because there's not a lot of methane in the environment. However, methane is way worse at holding heat than carbon dioxide is. When we talk about a greenhouse gas, right, we mean that gas holds heat and in turn heats up the world. Yes, carbon dioxide is our biggest problem because there is so much of it. But physically, if you take the same amount of carbon dioxide and the same amount of methane, methane holds way more heat. It is worse. The reason we don't hear about methane in the environment is because there's not much of it. If we continue to do this stuff with the methane and the fracking and the natural gas emissions, okay, methane has the potential to knock global warming just uncontrollable. I mean, it's bad enough where we stand right now with global warming and what we might have to do to fix it, or what we possibly could even do to fix it. There may not be much we can do. But you start adding methane in the mix, it's a done deal. There's no fixing it then, because methane is worse at holding heat than carbon dioxide is. And if we start getting methane emissions, it's done with. And then the other thing is increased earthquakes. Areas where there had never been earthquakes before. This fracking stuff, you are shooting hyper-solid, hyper-pressurized water and gases and sand into established rock beds. Heck yes, there's going to be earthquakes. And in places where there haven't been earthquakes before, the land is easily knocked around. If you have earthquakes on a regular basis, the land starts to settle and shift and kind of solidify itself, and it can handle a certain amount of shaking. If you have earthquakes in an area where there previously weren't earthquakes, then everything is going to start to fall apart a lot more easily. All right, you're going to have a lot more damage when you have these earthquakes. All right, so fracking for natural gas, advantages and disadvantages. So the advantage for fracking, you have ample supplies. Okay, there's a ton of it available. That's the main thing. There is a ton of it available, and therefore it's lowering the prices. It's a very versatile fuel. We talked about all the different things you could use natural gas for. It has a medium net energy, okay, which means, we're getting a good bit of profit for the work we put in. Burning it is going to get fewer pollutants than coal. Okay, so burning natural gas is cleaner than burning coal, way cleaner. You have less carbon dioxide emissions, and then you have the jobs available for the people who are doing the fracking. Okay, so those are the advantages. Like I said, this is a really hot topic, and you guys will need to be voting on this soon. This is coming up in almost every election where they have something about the fracking in there. Okay, all right, so the disadvantages, has a very low net energy for the LNG. Remember, that's the one that when we're trying to send out the methane, we pressurize the methane, that's the LNG. It has a very low net energy because of how much effort it takes to pressurize that methane. So it's a very low net energy for that one. The production and delivery is going to lead to carbon dioxide and methane emissions. When you're driving those tanker trucks, or when you're driving the semi trucks, when you're driving the big boats, whatever the big boats are called. Okay, all of that requires gasoline and releases carbon dioxide in the driving of those things. You have increased earthquake activity, like we were just saying, and the fracking is going to use and pollute huge volumes of water. Our fresh water is limited. The amount of water that we have on this planet that is fit to drink, even though it rains down and rains down and rains down, the fresh water that we have available to drink is very, very limited. And we start polluting that stuff up, we don't have anything to drink. Okay, and the wastewater that they're using for this fracking is going to ruin the groundwater. Okay, it's going to seep up in there, and all of the rivers and streams are going to be ruined from it. Okay, so now we get into social factors of this. Like I said, this is a huge, huge powder keg, meaning explosive situation in Congress and in all the voting things, because there's a lot of money to be made. If we increase our our natural gas reserves, then the U.S., here's the only plus thing. If we increase our natural gas reserves to the point where we do not need foreign oil, think about it. If we can get natural gas built up to the point where we don't have to go to the Middle East for our oil, then we wouldn't have to go to war with the Middle East for anything. Almost every war that we've been in, like I said, wars get started because somebody wants somebody else's stuff. And the U.S. is quite often the aggressor. Even though we pretend we're good people, it's usually we are quite often the aggressor. And if we have our own supplies, then there's no reason for us to get involved in anybody else's business. Therefore, there's no reason for a war if we have what we need. Okay. All right. So that's the only positive thing about this. Okay. So the pressure from powerful companies and lobbyists resulted in the fracking being exempted from several federal environmental laws. We have environmental laws that are designed to help keep the world from getting messed up by businesses. But when we thought about the idea that we really, really wanted this natural gas, then the sneaky folks behind the scenes got the fracking exempted from all of the laws that are supposed to keep the world clean. The Clean Air Act, it's not really about clean air. The Clean Water Act, not really about clean water. It's supposed to be, but fracking doesn't have to follow these laws. The Safe Drinking Water Act and the National Environmental Policy Act. All of these laws are in place to help prevent damage to the environment by big businesses. All of the big businesses are supposed to follow these laws, and if they follow these laws, they're not going to ruin the world. Fracking does not have to follow any of these laws. Therefore, they can do whatever the blankety blankety blank 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 they want to do to the environment. They don't have to follow these laws. Sounds really wrong to me. And that's why when you're voting, you have to be very careful. These guys came under the back door. Okay, the good people were trying to vote on clean water and clean air. Okay, but these guys came under the back door and got fracking taken off the list so that they don't have to follow it. So you have to be real careful what's going on with these businesses. So if we're taking a stand, so once we realized that they got exempted from having to follow the laws, okay, a lot of people have like stood up, okay, and the people where they're doing fracking in their neighborhoods, okay, this stuff is a mess. Like I said, earthquakes and gas leaks. And so the people who live there have been trying to fight against it. Okay, so a lot of concerns over fracking. Some of the states and cities and towns, they try to group up and get together to ban it. So before 100,000 more wells were drilled over the next 10 to 20 years, analysts call for the following protective measures. So what they're trying to do, the people who are trying to stop this, says, okay, if you're going to do fracking, it does have some good points, but you have to follow the laws like everybody else does. If you're going to do the fracking, fine. You have to follow the laws like everybody else does. It's only fair. So the first step is eliminating all these exemptions from the environmental laws. If you're going to do it right. stricter regulation and monitoring. You can't just blow the place up and don't care about it. You have to monitor it. Somebody has to watch over your shoulder to make sure you're doing it right. We need better data on the impacts of the fracking and the gas leaks. And you need to repair the existing leaks of production and distribution system. So that stuff's leaking out. Such efforts would limit the air and water pollution risks and avoid public backlash against fracking. So if the fracking companies are following the laws correctly, there'll be fewer and fewer people picketing outside their businesses. All right, so moving on to coal. Okay. Oh, I thought I had a picture of that thing for that lady. It's in there somewhere. There's a real, craziness thing where this lady's water catches on fire. Her water catches on fire. Okay, it's in here somewhere. I'll get to it soon. Okay, so coal is the next one up. Okay, so we've done oil, and within the oil you have the heavy oil and the tar sands. Okay, you have the regular crude oil, then heavy oil, tar sands. Then we did natural gases, and now we're talking about coal. Okay, coal is what we use a lot of around here. Okay, so coal formed from the remains of land plants buried and exposed to intense heat and pressure over 300 to 400 million years ago. So again, these are where the land plants get buried. It's a solid fossil fuel, whereas of course oil is liquid. This is turned into little rock type things, and it's burned in the power plants and industrial plants, and it's the most abundant fossil fuel. This is the one that we have the most of, and it's about 40% of the world's U.S. electricity, and I'm pretty sure that's what we have here for your MLGW. The U.S. figures are dropping as we increase to the natural gas, because again, the natural gas is cleaner. Okay, so we are shifting gears to the natural gas as long as we can keep the fracking people doing it right. So it is shifting, but at the time we printed the book, it was about 40% of the U.S. was coal. And it's also burned in the industrial plants when we're making steel and cement and other stuff. So it's really, really, really common. Again, here's another question. Again, who has what? Who has how much? And how much are they going to fight over it? So like I said, I'm going to put all these together on one worksheet so we can talk about, like, again, the reason we need to know is wars are fought over taking somebody else. Okay, so here is a coal plant to show you. Okay, what they do is they bring the coal in here and send it up, okay, down into this big giant silo looking thing, send it across here and burn it. The whole reason they're burning this coal is just to boil this water. Once you boil this water, you're making steam. If you can spin this, if the steam will spin this turbine, then you can make electricity, because all it takes, you have a coil of wire and a magnet. You can either have the coil of wire in the center and the magnet on the outside, or you can have the magnet in the middle and the coil of wire on the outside. Whichever way you set it up, if you can spin one inside the other, coil of wire and magnets, if you can get that to spin, you've got electricity. That's all you need to make electricity, is spin those wire and that magnet. You don't need to do anything else to make electricity. Electricity is that easy. All you need to do is spin a coil of wire around a magnet, or a magnet around a coil of wire, and then you got electricity. So in this case, for the coal plant, what they're doing is they're burning all of this coal, making all of this smoke and this carbon dioxide, all of this mess, just to boil water. And then the steam is going to spin the turbine, which is where the magnet and the wires are, and it creates electricity. And then the water, once it's so hot, comes down here to this cooling facility. Yes, this looks like a nuclear or something or other, but it's just a cooling facility for the water, and that's just steam coming off the top. Comes back down once it's cooler and starts back again. So the water is supposed to be held in a loop. Now this is going to be pretty dirty water, but if you keep it contained, you can use it and use it and use it again. Down here at the bottom, once the coal has burned, the ashes and the stuff and the bits, they go down here through this filter. This truck takes it for stuff like asphalt and things of that sort. And then it's filtered here, and you can, I think, in this little thing, reburn it some more for some additional electricity. Okay, so burn it a little bit more and get some more products from it. So that's how a basic coal, and this is how most of MLGW works. All right, so there is a lot of times they say, you know, when they're trying to get your votes about these coal plants. They'll say, well, it's a clean coal. No such thing. No such things. Check this out here on 371 and 72 in your book. Okay, it's the dirtiest of all the fossil fuels, meaning when it goes out, not only does it put out carbon dioxide, but you have soot and nastiness everywhere. The coal mining process will severely degrade land and pollute the water and air. If the whole idea of digging this coal out of the ground is horrendous, what it does to the environment and what it does to the poor people who have to do it. It's horrible. Burning the coal is also going to release various pollutants into the atmosphere. Like this is 39% of our global emissions of carbon dioxide. Okay, so we want to know what carbon dioxide we know is messing up our air. It's the coal power plants. Okay, and it also is the coal power and the industrial plants are also the largest emitter of all of the greenhouse gases. So it's not just carbon dioxide, it's methane and everything else contributing to the atmospheric warming and climate change. It's the dirtiest of all fuels. Do not believe anybody when they try to get your vote that they say that it's clean coal. There's no such thing as clean coal. All right, burning coal is also going to convert sulfur in the coal to sulfur dioxide, which causes acid rain and serious, serious health problems. My family, when we were young, lived in Ohio for a while, when I was about kindergarten age, before we moved to the farm. And my littlest sister was born in Ohio, and there's tons and tons and tons of factories there and lots of pollutants there. And it's just really, especially when the car industry was real strong. I'm talking 70s. Okay, so this was a long time ago. But my littlest sister it was so bad with all the factories that, oh, I've got to stop fourth period. Dang it. Hold on. I'll tell you more about that in a second. All right, so let's continue this. I had to go, it was fourth period. I was letting you guys into class and check and roll and everything. So let's continue. So whenever you are coming across the voting and the stuff you need, the politics and all that stuff, if somebody is coming across telling you that they've got clean coal, they do not. There is no such thing. And right now, China is one of the world's largest emitters of carbon dioxide and sulfur dioxide. They are the biggest of the coal burners in the whole world. U.S. is second. All right, so the two biggest countries in the world are the biggest polluters of coal. So what can you say about our global warming chances? All right, so both U.S. and China has to come down off of our coal. Otherwise, the global warming is not going to be under control. And burning the coal makes the soot, okay, which is the mixture of very fine particles and chemicals, acid, dust, and metals that, I don't know if you've ever burnt candles and you see that black stuff that gets on the edges of the candles. They're so small, but they can collect deep in your lungs. That stuff can get in your lungs. That's what I was trying to tell you guys about the health issues. My littlest sister was born in Ohio in all of that factory smoke. All right. She was and still is much smaller than my other sister and I. We were born where we could breathe, and she was born in Ohio, and for her beginning formative years, she stayed there from birth to about 4. Okay, and she never grew strong. Okay, and that pollutant, that coal smoke, has a lot to do with health issues, premature death, heart attacks, strokes, breathing problems. Okay, all of that stuff comes from these pollutants. And so some of the coal burning plants are going to install air pollution control equipment called scrubbers. Okay, it's basically a super duper filter on the top of their smokestacks. Okay, they remove certain pollutants and collect them as ash before they get out of the smokestacks. Okay, that helps a lot. Okay, so this proper control equipment can significantly reduce the harmful emissions from burning coal. However, this type of pollution prevention is going to reduce their net energy. These are very, very expensive to install and to maintain and to be sure that they're working right. And you know, anytime you have a filter, you have to clean out the filter. Anytime you have a filter, you have to clean the filter. All right. And so it's very, very expensive to install, very expensive to maintain. It's going to eat into their bottom line. Therefore, a lot of them are not going to do it. And so while most of the U.S. coal burning power plants, we have the scrubbers here in the U.S. Um, because they give us subsidies for it. There's enough environmental resistance that if they find out you're using a coal plant and not putting scrubbers on your filters, people are going to be throwing rocks in your windows and picketing on your doorways and all that stuff, because here in the US we care a lot more about our environment than some of the others. China, though, burns a lot more coal than we do, and India is a pretty close third. They don't use these air pollution control equipments. First off, their economies are not set up for it, and particularly in China, you're not really allowed to argue with something at all. Okay, if something is set up and running a certain way, you're not really allowed to disagree with people if you don't like how it's running. And so China and India are pretty much not using scrubbers. Okay. And so, again, that's where we're getting into a lot of trouble. There is no clean coal. Do not ever believe somebody if they tell you that. So getting into the advantages and disadvantages, and again, here's another one of these little blue tables. Okay, the advantages: you have ample supplies in many of the countries. There is a lot of coal available. It's medium to high net energy. So we can get a lot of high net energy means we're getting a lot of money for our effort. Okay, and it has a very, very low cost if you don't include the environmental and health damage. The fact of just digging it out of the ground is not very expensive if you don't count the environmental and health damage. So it has a pretty high net energy if you're going to be closed-minded like that. The disadvantages is you have very, very severe land disturbance, water pollution, fine particle and toxic mercury emissions. Mercury will kill you in a minute. It'll give you like, oh, it's really bad for you. And so lots of air pollutions, and when you're producing the coal and when you're burning. The future of coal, let me make sure that wasn't important. Hold on. This one is important. Just a second. Okay. So coal is getting a lot of competition from the cleaner resources. Like we said, natural gas is replacing coal in a lot of the markets. Cheaper natural gas, wind power. Oh my goodness. Wind power has such a great potential. Like I said, we'll get into that in the next chapter. If we can have wind power replacing these coal plants, then everything will be great. Okay, so very few new coal burning plants are being built in the U.S., and some of the older ones are being closed down. So we are phasing coal out of the marketplace, which is a good thing. Natural gas is on track to overtake coal as the largest fuel source by the 2030s. So within the next 10 years, we should be switching the numbers. There'll be fewer and fewer coal and more natural gas. It would overtake it sooner if the U.S. would be stronger with their regulations of the greenhouse gases, because there are fewer greenhouse gases emitted in the burning of the natural gas than there are in the coal. If we were stronger with our greenhouse emissions, then the coal plants would shut down even faster. All right, hold on just a second. So what we were saying is that if the U.S. would strengthen our laws on gas emissions, then we could help reduce the atmospheric warming and climate change. Wow, that's a lot going on right now. Okay, all right, so let's see what's next. Oh, our quick check. We are done. How amazing is that? We are finished. Okay, so these again are a quick check of core, and they usually come in with our questions at the end of the chapter. Again, as I said a moment ago, most likely some of these, you go ahead and answer them here on your notes. Go ahead and answer them here on your notes. If they do show up on a worksheet later, you can just copy and paste it onto the worksheet, okay? All right, that is that. And so you guys have a great day. Thanks.